Okay, I don't think I have my audio over here. Sorry, what? My headphones over here. I hope that's not an issue. देखते हैं what the audio is like later on. Okay. So yeah, I'm studying this now. Not this. I'm studying this. Yeah, that thing got pushed. I think our basics पे था. Learn about coroutines, how they're different from. A coroutine is what is returned by an async function. We'll learn about coroutines. And why are they returned by async functions instead of normal values like regular Python functions too. Give an idea of when to use in a async function. Is the same. It's not. It's not. Let's just start here. It is what is returned by an async function if you don't await it explicitly. An async function is an object that is returned by an async function if you don't await it explicitly. An async function is the same as a Python function with the added functionality of pausing its execution with the help of some dedicated syntax. As such, they behave quite differently from regular Python functions, even if they look very similar in terms of code. You use async to define I think I've asked this question now, very honestly speaking. Also, I think I keep going back to this chat. Is a coroutine the same as an async function? I'm asking very dumb questions right now. The function definition itself, it's a callable, just like a regular function. The object returned when you call an async function is what a coroutine is. This is what actually gets awaited and executed. This function produces a coroutine, awaited produces a result. I think this would help. Async function called produces a coroutine, which when awaited produces a result. Make sense? Makes sense. Notice how the coroutine doesn't give answer. It gives a coroutine object. The coroutine object is then awaited to can only be done in event loops. Fine. We are good, I think, so far. तो 15 को बंद करते हैं. Yeah, I think this is chill. Sorry. We were here. If there's a distinction, then isn't this line misleading? I read it in a textbook. Several applications concurrently, which can give our applications a big performance improvements to both create and pause a coroutine. We will need to learn to use Python's async and await keywords. The async keyword will let us define a coroutine. Async keyword will let us define a coroutine. Yeah. Pause a coroutine. मतलब async function long running operation. Which Python version should I use? Yeah, fine. Creating coroutines with async keyword. Coroutine on the event loop वो सीधा ऐसे execute करके दे देगा because there's no await basically उसमें. But we are creating something very different from a plain Python function. To illustrate this, let's create a function that adds 120 integer as well as a coroutine that does the same and compare. Yeah, fine. Method result is 2 on the top. Notice how when we call a normal add-on function, yeah, fine. The coroutine of shit instead. This is an important point as coroutines aren't executed when we call them directly. Coroutine is so what's a coroutine? Why do they exist? Instruction to resume from instruction pointer local variables string on local variables. In a normal function call the frame local variables and instruction pointer on the call stack destroyed. Coroutine can't do that. It needs to pause and resume. So its frame is moved to the heap where it persists between the assumptions. stored on the heap. Inspect it. Essentially a suspended function frame on the heap with enough state to be resumed later. The bytecode itself isn't copied, it's shared. I am going a little too deep. I do realize that. Coroutine result. Source. I'm sorry, I'm bad at being very nimble at writing code. Just bear with my pace over here. Coroutine result. No, not the result, sorry. Frame. Shall we good? Coroutine what? Coroutine code. It's some sort of a code object, and the file that is mentioned is something line 3. Line 3. Okay, it starts at line 3 is what you're saying. Coroutine and 1, x is equal to 1, y is equal to 2. फ्रेम करता क्या है फिर? Can we print the local variable slash instruction pointer via the frame? वैसे I shouldn't use my regular cloud. I should use my work का cloud. Can you print the local variable slash instruction via the frame? F locals. I see. Frame locals number 1. What? समझा नहीं मेरे को ये. आई थिंक दे मतलब पास्ट. बट तुम इनके लोकल्स क्यों नहीं काउंट किया तुमने? I shouldn't use this. Yeah, I'll just get my work profile over here. I know, I think you're the tamer one. I'll just put this here, maybe here. There a way I can print the locals of this coroutine? F locals. What? Oh. Task asyncio dot ensure future. What the fuck is an ensure future? I am going in the rabbit hole right now. CR frame F locals. Suspension point. I need a suspension point. Okay, let's keep this here. This is turning out to be a little too deeper than I was hoping it would be. I say keep this. This is nice. Instruction executed. No problem if you don't understand this right now. Just managing expectations at this point. What do you mean instruction pointer? I did not get that. 2. What does that 2 mean? छोड़ो यार, ज़्यादा हो गया. Also, yeah, मतलब a coroutine is this. The suspended function frame. This kind of flew over my head, dude. Between what? Distinction between what? Regular Python functions / async functions. It's fine if this goes over your head right now. A frame is kind of a runtime context for any function, be it regular or async. It contains local variables, runtime, what? Instruction pointer, the byte code of the reference to the byte code. What? It contains local variables, instruction pointer, this is the byte code, that function, and a few other things. For regular functions, this frame exists on the call stack. For async functions, however, this frame exists in the heap. As such, it can be suspended, the frame. Do you mean when you say that frame can be suspended? Suspended meaning that frame can just be left untouched while the event loop pauses the task and does picks other tasks. Since it's on the heap, the frame survives between resumptions of the code in the async function. This allows the event loop to pick up the task where it left off. For a regular Python function, there's no possibility the frame suspending. Call the function. That function is going to run from start to end with no pause. Start to end with no pause, destroying the frame with as its execution is finished. No point persisting the frame. Use the search. It's fine if this goes over your head right now. A frame is kind of a runtime context for any function, be it regular or async. It contains the local variables, the instruction pointer, a reference to the bytecode of the function, and a few other things. Now, for regular functions, this frame exists on the call stack. For async functions, however, this frame exists in the heap. More precisely, we are talking about async functions which actually use the await mechanism. There is no compulsion, by the way. You can just say async def whatever function and then just write the definition of a synchronous function inside of it. So उस case में I'm assuming I don't know what happens actually in that case. Yeah, I'm not very sure what happens in that case. More precisely, we are talking of async functions which actually use the await mechanism. As such, the event loop can afford to work with the frame as such for to work with the frame and then just leave it alone when it needs to, and the frame will still be there when the event loop comes back for this task. Suspended meaning that the frame can just be different touch. For a regular Python function, notice how the async function is given an answer. It gives a coroutine object. Coroutine is awaited to fetch us the result of the code. Coroutine. Yeah, I think we are good. In an async, yeah. Okay. Async IO. Is doing a few important things in this scenario. Creates a brand new event loop. Okay, this is page 26, isn't it? Event loop. Once it successfully does so, it takes whichever coroutine they pass into it and then runs it until it completes, returning the result. This function will also do some cleanup of anything that might be left running after. Yeah, it has some garbage collection thing after it. After the main coroutine finishes. Once everything is finished, it shuts down, closes the event loop. Possibly the most important thing for async IRA is that it is intended to be the main entry point. its own coroutine, and that coroutine should launch all other aspects of your application. As you progress further, we will use this function as the entry point into nearly all of our applications. Async, you will very likely use this async io.run call in every program of yours which uses async io. It's supposed to be the gateway into the event loop. As such, use it exactly once. As such, this call must execute a main coroutine which sets into motion all of your other coroutines. Pausing execution with the await keyword did not need to be a coroutine. Executed only non-blocking Python code. The real benefit of async IO is being able to pause the execution. You need to pause execution to let the event loop run other tasks during a long-running operation. Call to a coroutine, more specifically an object known as an awaitable, which is not always a coroutine. Here too, shouldn't it? No, just go to the work account. And you need cloud code. I read this from a textbook. I had a question pertaining to this blurb of text. Shouldn't it say call to an async function instead of call to a coroutine? I thought coroutines are objects returned by async functions. You can't call a coroutine. Isn't that correct? Technically a coroutine function. Call a coroutine object. For the love of God, a coroutine is what you actually await. Await some async function, calls a coroutine function. Okay, they are usually, sorry, what? Loosely used. Usually loosed, it seems. Okay, what the fuck? this means that I think I'm going to study for 30 more minutes, okay? Like once I come back from lunch. What it is trying to say is that the coroutine that contains that await expression cannot be continued any further until that await expression returns a value. Am I right over there? Freezes in place at that line and does not move to the next line until the awaited thing completes and gives back a result. You don't just go ahead. This never happens. Coroutine will not reach print after until some long operation finishes because they know you need it. They know you need. It's not just gonna go ahead. Let's do some shit. No, it's not gonna do that. What happens during the freeze? The coroutine is paused, but the event loop doesn't just sit idle. I do get it. I do get it. I understood that after an await, both. No, not both. When a coroutine hits an await, that coroutine task is essentially taken off the table for the event loop to consider, and the event loop is free from any other pending task. The block task only gets.
लोकेशन धाडपालाय मातशें आं बरें बरें आनी कितले तुमी भायर सरतना म्हाका फोन लायतले नाल्यार आमी लेट जातली चड हय तुमी थंयच्यान हरशीं थंय एक म्हळ्यार पावल्या कोता येता मुगो बारेक काय बारा
Okay.
हय हय कळ ना ना आनी लागीं देवूळ बी न्ही लागीं देवळां वचूं जाय न्ही थोडीं देवळां ना थंय ती हय आनी
Okay, I think that's enough learning for now. I'm gonna stop streaming. I'm gonna do. I'm not sure if I should do 30. I'll do 30 more minutes. Okay, just to be sure.